Next man on stage is Fredrik Wulff from the Baltic Nest Institute, and he also represents the University of Stockholm, Sweden.
Okay, thank you very much. Thank you for inviting me, and I was asked to talk about this issue, what we can and cannot expect science to deliver. And it's interesting. I mean, 20 years ago I climbed down from the academic ivory tower and started to participate in programs linking science and management, and my view of the role of science have changed quite dramatically during these years. And first, a few words what science can help to do. We can define operational environmental targets. A good example you will hear after me from Jesper. I mean, a politician or the general public must say things like a good environment, but it has to be redefined in specific numbers and criteria. And we are now pretty good at that. We can also show what is needed to reach specific environmental targets. The Baltic Sea Action Plan is a good example of that. We can show how much nutrient load should be decreased to reach these targets in the different areas. We can do things for fishery management. We can show maximum sustainable yield for various fish stocks and so on. And we can also describe the relative importance of various factors influencing pollution. For example, we can show that it's not enough just to have high-level sewage treatment plants all around the Baltic to reach this goal. You have to do something about agriculture as well. And you can define how much you can improve the environment by whom. And we can also now calculate the cost and cost alternatives to reach a specific targets. In the recent bonus sets, for example, a minimum cost solution for the Baltic Sea would be to reach the eutrophication target would be about 5 billion euros per year. But maybe more interesting to discuss is what specific natural science cannot define. And first of all, what is a good Baltic Sea? Jesper can set criteria, but they are criteria set of scientists. But what is the criteria by the general public in what's good enough, and how much is it worth? I mean, some of the criteria we are set for the Baltic Sea, are they acceptable from a human point of side, and how long can we wait? As a scientist, for example, we know that year 2020 we have not reached these goals. In no way you can restore a Baltic Sea until 2020, and it's still the official goal. We can reach goals faster with a decent fishery management than we can reach them in terms of eutrophication, and we might speed up recovery if we do some drastic measures like ecological engineering. Are we willing to take the risk for that? And which measures are politically and socially acceptable? I mean, we know that in order to reduce the load of nutrients of the Baltic Sea, we have to reduce the loads from agriculture. There is no way we can run the agriculture the way we are running it today. There are also projections for the future that if Poland and the other transient countries would have the same agriculture as we have in Denmark, for example, I mean, the loads from agriculture will increase dramatically in the future. Are we willing to implement drastic reductions in agriculture? The farmers are not going to pay it. It's a consumer. We have to. There are methods to reduce the loads, but the cost of meat, agriculture products, will reach drastically. Is this something that can be accepted? And finally, how to implement measures. I mean, we can say so many tons of nitrogen should be reduced in agriculture. But the natural science, I mean, we are not the ones who say, how do you set up laws? How do you set up regulations which actually achieve this? And how do you implement measures in fisheries, for example, which do not invite to cheating, for example? And in many cases, these things are very poorly understood. So we can do things for some parts. Eutrophication, fisheries, and also I think shipping is things that there are lots of science available to make decisions. But there are other fields where we are far from setting numbers on things. Toxic substances. If you look at the Baltic Sea Action Plan, you can see in those sections there are the leading lines are further study needed, and there are lots of aspects still remaining before we can do substantial action plans like for eutrophication. And then we have things like unexplained event, and I will finish off with showing some examples of that. Here's a Swedish example, eider ducks in Stockholm archipelago. From 85 to now, actually, the eider duck population have drastically reduced in the Stockholm area. It's halved, and it hits all the birds eating mussels. It doesn't hit fish-eating birds. And there has been a number of workshops on this, and there are, I think, 6 or 7 different hypotheses. Why is this? Ranging from that the sea eagles take them, the increasing seagull population, to an unknown toxic substance, and everything in between. Simply, we don't know. Another example is coastal fisheries. We are proud that we are getting back offshore cod populations now. But I spend my summers on the island of Öland. And this is a picture from last summer in a little fishing harbor. And dramatic changes have happened during the last 5 years. Most of the boats are gone. The few are remaining lies this idle, rotting away. And when you talk with the fishermen, they say there are no fish out there. And also, it's not worth fishing because there are too many seals. And this is a complicated issue of interactions. I mean, we are proud that we get back the seals, but getting back the seals wipe out a traditional way of doing fishing that developed during the years where there were no seals. And And there are many dimensions on such a problem, which is not only natural science. So, challenges. We need truly interdisciplinary science. Marine and terrestrial communities should work together. Institute versus universities should cooperate. And I would say things are rapidly improving there. I would say this last bonus round was very fruitful in that. In many of the programs, cooperation between these traditionally separated organizations were joined. And bonus also contributed that environmental economics, political science, and law, etc., comes into discussing management options. And it's been usually us natural scientists who have been driving environmental studies in the sea. Now a much broader community must come in order to find solution to the issues. A challenge that we natural scientists have is our deeply inherited hesitant to give advice. In spite of that, we are not really certain. We want 3-star statistical significance between numbers before we say, yes, there is a difference. And often when we present our information, we say, well, maybe possible we have a hypothesis, but further studies needed. And then, of course, nobody will listen to us. I've learned to working with social scientists that they are used to give advice in spite of uncertainty. And also to define achievable environmental targets. Many of these official targets are like the Baltic Sea unaffected by pollution. But we know so much now, so we can discuss it in a more realistic way. And finally, we have to learn new ways to communicate all this information in a way that our traditional schooling were not adapted to. Thank you.